Alright, so for this video we're going to talk about limiting reactants and excess reactants. Sometimes you'll hear them called limiting reagent or excess reagent. So basically what a limiting reactant is, it's the reactant in a chemical reaction that prevents the reaction from progressing or from continuing. Basically it's what runs out first. And the excess reactant is what you have extra of or leftover of. Basically you have plenty of it. So a good example I like to use is, let's say you have a piece of paper, right? And you were to set that paper on fire. Okay, I know that's really terrible flames, but bear with me. So you have a burning piece of paper in a large room. So, you know, you guys have probably seen enough fire to realize that the paper most likely is going to burn up first because you have plenty of oxygen in the room. So in that case, your paper will be your limiting reactant because once it's burned, it's gone. And your excess reactant is going to be the oxygen in the air. Now, the only exception would be if you were to cover up the burning paper with a box or something that smothered out the fire, which basically means you're cutting off the oxygen, in which case oxygen would be the limiting reactant, and your burning paper would be the leftover reactant, or the excess. So those are generally the two key terms for this section. We're going to learn how to calculate limiting reactants now. So we got a reaction here. Nitrogen and hydrogen will react to form ammonia. Okay. First off, let's balance it. Okay. So it's asking us what's the limiting reactant and how much ammonia can be formed with this reaction, ammonia being NH3. So the thing about calculating limiting reactant is you have to predict the amount of product anyway. So let's go ahead and skip to the second part of the question here, how much ammonia can be formed. So let me give us some amounts here, 10.5 grams of hydrogen and 6.2 grams of nitrogen. Okay, so let's go with that. So how much ammonia can be formed is the first question. So we've got 10.5 grams of hydrogen. Let's find out how much ammonia we can make with that. So with 10.5 grams of hydrogen, okay, first step, convert it to moles. There's 2.02 grams of hydrogen in 1 mole. Alright. Second step, we have to use the mole ratio here between hydrogen and ammonia, which is 3 to 2. So there are 3 moles of hydrogen for every 2 moles of ammonia. Okay. Final step, convert moles of ammonia to grams using the molar mass of ammonia, which should be 17.03, I believe. So in a mole of ammonia, you have 17.03 grams. Okay? So if we do the math here, we find that we have enough hydrogen to produce, hang on, need a better calculator. To produce 59.01 grams of ammonia, which is a pretty good bit. Okay, so we have enough hydrogen to make 59.01 grams of ammonia. So let's do the same thing with our nitrogen. So we said we have 6.2 grams of nitrogen. Okay, molar mass of nitrogen of N2 is going to be 28.02 grams in 1 mole. Again, just get that from the periodic table. Alright, now you need 1 mole of nitrogen for every 2 moles of ammonia. And again, I got that from the mole ratio from our equation. 1 mole of nitrogen for every 2 moles of ammonia. Okay? And that's awful. Alright. So, last step, for every 1 mole of ammonia, you have 17.03 grams of ammonia. Okay, do our calculations there, and you should get hang on, 6.2 divided by 28.02 times 2 times 17.03, and you get 7.54 grams of ammonia. Okay, so how much ammonia can be formed was the question. Well, our hydrogen tells us we can make 59.01 grams of ammonia. Nitrogen tells us we can make 7.54 grams of ammonia. Well, it turns out this number doesn't matter at all, because once we've used up all our nitrogen to make this, the reaction is done. So that is our answer. We have enough of both reactants to make 7.54 grams of ammonia, which means our limiting reactant here was nitrogen. So basically, you're going to predict the amount of product you can form with all of your reactants, and that will tell you which one is limiting. Whichever one can make less product will be the one that limits you. Okay. What I want you to do now, I'm going to give you another example. I want you to pause the video after I give it and try the problem on your own. So, we have hydrochloric acid reacting with magnesium here to make magnesium chloride and hydrogen gas. You're given 2.02 grams of magnesium and 4.05 grams of hydrochloric acid. I want to know how much of each product can you make and what is the limiting reactant. Okay? So, I'm actually just going to work this one on pause just to save some time. So pause it or unpause when you're ready to see the solution. Alright, so now I've gone ahead and worked this one, so you can take a look at it, and I will walk you through what I did. So, what I started with up here, okay, I decided to first see how much magnesium chloride I can make. So, I started with magnesium to see how much magnesium chloride I could make. So, 2.02 grams of magnesium, okay, use the molar mass to find moles of magnesium, and I use the mole ratio to find grams, or to find moles of magnesium chloride, and for the last step, I found grams of magnesium chloride. So our calculation was that we have enough magnesium to make 7.91 grams of magnesium chloride. Now I did the same calculation for hydrochloric acid, and it looks like we have enough hydrochloric acid to make 5.29 grams of 5.29 grams of MgCl2. Okay, so looking at these two numbers, it's pretty obvious that that's not going to happen because we're going to run out after 5.29 grams of product is made. So that means hydrochloric acid is going to be our limiting reactant. They can make less product. So we can go ahead and jump down here and say hydrochloric acid is going to limit us. We're going to run out of it first. So this will actually save us some work because we only have to do one calculation for our other product, which was hydrogen. Okay, we found out how much of this we can make. 5.29 grams. Okay. Now, since we know that hydrochloric acid is our limiting reactant, we can just use it to see how much hydrogen we can make. So I've already done the calculation for you. Okay. And it looks like we can make 0.112 grams of hydrogen. So if you got that, awesome. If you did not get it, I would advise doing more problems because this is basically going to be what you're going to see on the test and what stoichiometry is in general. It takes practice, but you've got to be able to do it. So just do some more problems. They're easy to find on the internet. You can probably make some up, or just go look at past reactions and just test yourself on those.